This work focuses on the development and creation of a multilingual terminology database built with the support of neural machine translation in the field of neurology. Terminology is the discipline that studies the concepts and terms of a specific sector with the aim of describing their correct use. When we talk about medical terminology, we refer to a set of highly specialized words used to describe diseases, procedures, instruments, and every aspect related to medicine in a precise and effective way. This technical language has a fundamental characteristic. It must be unique, because even a minimal terminological error can compromise communication between healthcare professionals and translators. To manage this vast amount of terms, we use terminology databases, which are not simple dictionaries but tools for collecting, managing, and consulting terminology, useful both for translation and for the standardization of technical specialist language. It is important to understand and underline that terminology databases require constant updates to reflect the evolution of medical research and often have a digital structure to be integrated into clinical software or translation assistance systems. In the medical field, the most widely used databases include SNOMED-CT, an extremely detailed clinical coding system that describes symptoms, diagnosis, and medical procedures. ICD, International Classification of Diseases, mainly used for coding, diagnosis, and clinical documentation. And medical subject headings, a controlled vocabulary used by the National Library of Medicine for indexing content on the PubMed search engine. In this work, I relied on the neural machine translation. This is an advanced technology in the field of automatic translation introduced in 2017, which uses AI models based on neural networks that replicate the cognitive process of a human translator by analyzing the entire sentence to understand the context. DeepL is one of the best-known examples of this system. It breaks down sentences, analyzes their structure, identifies syntactic and semantic relationships, and uses neural networks trained on large amounts of multilingual text to generate accurate and high-quality translations. The chosen branch for this project is neurology, in response to the growing need for reliable medical translations and for accurate, functional, and internationally shared terminology to support medical scientific translation activities. Medical language also presents peculiarities that make it extremely complex and unique. The frequent use of acronyms, the presence of eponyms, which are terms derived from the proper names of doctors or researchers, and the systematic use of prefixes and suffixes of Greek and Latin origin that precisely define medical concepts. My work was structured in several phases. The first one was the collection and selection of terms. I identified relevant neurology terms by consulting sources such as medical terminology databases, clinical neurology manuals, and specialized medical dictionaries. The terms were organized into two main conceptual categories: neuroanatomy and neurological diseases. The second phase was translation. I translated the terms into English, German, and Russian using neural machine translation systems like DeepL, always integrating manual revision through terminology databases and specialized medical resources to ensure terminological accuracy. Database structuring. Each term was entered into an Excel spreadsheet with its unique ID, Italian definition, semantic category, equivalents in the three target languages, consulted sources, usage context, and additional notes on synonyms. This research is a reflection on the innovation of medical terminology and a concrete contribution to the development of multilingual terminological resources supporting linguistic mediation in neurology.